All right, so today we're going to learn about 10.4, which is the hyperbola. So a hyperbola, by definition, is the collection of all points in a plane where the differences are called the foci. So hyperbolas look like this. So we have a center, just like with an ellipse. The center is going to be h comma k. It could be at the origin, just like ellipses. And then we have vertices, just like with our ellipse. The vertices are still going to be found by moving A. Instead of this being called the major axis, it's now called the transverse axis. And then this one here is the conjugate axis. We still have foci. So with foci, it's kind of like a parabola where they're outside or inside of the two parabolas in a way, right? Our parabolas kind of look like this. Just like with ellipses, to get to the foci, you move C. Okay, so we would move C in either direction to get the focus of our hyperbola. Now, one thing that's a little different with our hyperbolas is we also have asymptotes. So that's going to determine how wide they are. So we'll have two asymptotes here that will go through the center. Now our equation for our hyperbolas have a subtraction symbol instead of an addition symbol. So with ellipses, it's a plus. With hyperbolas, it's a minus. So the form looks a lot similar to our ellipses, so you're going to have to really pay attention on the test. Is it a plus or is it a minus? Because if it's a plus, it's an ellipse. If it's a minus, it's a hyperbola. Some other differences is if you notice here in our equations, A is always the first one. So the difference between these two equations here is whether x squared is over a or y squared is over a. So we're not always going to have x first. So with hyperbolas, a is always first. So with ellipses, a was always the bigger number. A could be either under x or y. With hyperbolas, a is always the first one. Okay, when we're doing subtraction, order matters. So they're always going to have a be under whatever the first one is. Now, as you could assume, if a is underneath x squared, that makes a hyperbola that opens up left and right. If a is underneath y squared, then that makes a hyperbola that opens up or up or down. Okay, so we get a hyperbola that opens up or down. Then, of course, x is always with the h, y is always with the k, x is always with the h, y is always with the k when it comes to the center. Now, one other difference is how we're going to find C. So C still tells us our foci, but this time the formula is different. So instead of b squared equaling a squared minus c squared, now it's c squared minus a squared. Okay, so the formula, the c and the a switch spots. Okay, they switch spots. Now that should make sense because the distance to go from the center to the foci C is bigger than it is to the vertice compared to with an ellipse, right? When we had an ellipse, the foci were here, so the C was smaller and the A was bigger, so we did A minus C. Well, here the C is going to be bigger than the A is, so we have to do C minus A. Okay, so that's just an easy way to help you remember because the foci are further in than the vertices are. Now, we talked about these asymptotes, so the equation of the asymptotes are here. Now, if you notice, the only difference here is we have y minus k, h minus, or x minus h, x minus h. Now, the difference here is the slope. So depending on which depending on which way the hyperbola is opening determines if you do b divided by a to get the slope or if you do a divided by b to get the slope. So the way I like to remember this is we know that in algebra slope is always rise over run. Okay, that's algebra, we've known that forever, rise over run, which tells us y over x, right? The change in y over the change in x. So I like to remember it that same way. If it's parallel to the x-axis, that would be this equation here. Well, if you notice, the b is underneath the y and the a is underneath the x. So we're going to do b divided by a, the y number divided by the x number. In this one, we're going to do y divided by x, so y is a, x is b, so a divided by b. So I don't try to remember which one is b over a and which one is a over b. I try to think about it as I'm always going to put the y number on the top and the x number on the bottom. Okay, so let's look at some problems. That's a lot of talking, not a lot of problems. So our first problem here, it's kind of blurry. Let me see if I can focus this. All right, so the first problem, we want to find the center, the transverse axis, the vertices, and the foci, and the asymptote. So that's a lot of things we got to find. So let's start by finding the center. So the center here, x is always with x. So x here is going to be 3, comma, negative 4. So 3, negative 4. Now remember, with hyperbolas, a is always the first number. So a squared is 36, which means a is 6. B squared is then 4, which makes b 2. We are going to have to find c, so now b squared is equal to c squared minus a squared. We flip-flop these now, so we have b squared equals c squared minus 36, so 40 equals c squared, so 2 root 10 is c. All right, so now because the y is first, that tells us our hyperbola is going to be opening up and down. So we're going to move our a, which is 6, up and down from our center. So we're going to go 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So those are our vertices. So that's at 3, 2. And 3, negative 10. Now the foci are going to move from the center, and it's going to move 2 root 10. So that's going to be at 3, comma, from the center, negative 4, plus 2 root 10. And then 3, comma, negative 4, minus 2 root 10. So there's our foci. Then we are going to have to figure out how wide this is by knowing what the slope of our asymptotes are. So the asymptote is always y minus k. Well, y minus k is negative 4, so y plus 4 equals plus or minus the slope, and then x with h. So really, I'm taking this x guy here, taking this y. The only thing I need to worry about is what is the slope. So the slope, I always think of it as y over x. So the slope is y over x. Now the y number here is 6. The x number is 2. So that makes our slope 6 over 2, or 3. So our slope is plus or minus 3. So from the center here, we're going to go up 1, 2, 3 over 1, 1, 2, 3 over 1. In both directions. And then we're also, so there's one of them, we're also going to go in the other direction, plus or minus. So that was our positive 3. Now we need to do our negative 3 slope. So 3 over 1, 3 over 1, 3 over 1, 3 over 1. There's our other. So now we know how wide to make our hyperbola. And there we go. The last thing that we need to find is the transverse axis. Now the transverse axis, because it's opening up and down, that's going to be parallel to our y-axis. And specifically, the transverse axis is right here at the line x equals 3. Okay, so I know on MathXL, I think they just want you to type in the y-axis, meaning that it's parallel to the y. But if we're super specific, the axis is at x equals 3. It's like when Algebra 2 asks for the axis of symmetry, okay? So in B, we're going to have to complete the square before we can do everything that we did in 1. So we have x squared minus 4x. We're going to have to add a blank. Then we have y squared minus 10y. We're going to have to add a blank, equals positive 25, and then 2 blanks. Now, just like in ellipses, you're not allowed to have a number in front of y squared or x squared. So if we look here, technically speaking, there is a negative 1 in front of this y squared, which means I have to factor that out. So I have to factor out this negative 1, which is really going to make this a positive 10, because I have to factor out the negative 1. Just like if it was a 4, I would factor out the 4. So now I can complete the square. Half of 4 squared is 4. Half of 10 squared is 25. But this is technically a negative 1, so negative 1 times 25 is negative 25. Okay, so please make sure you're multiplying there, just like we did with ellipses. It's just that it's a negative instead of a 4, let's say. So this becomes x minus 2 squared minus y plus 5 squared equals 4. Then we're going to divide everything by 4. There's no simplifying that needs to be done, so now we are set up to finish the problem. So the center here is going to be at 2, negative 5. Now we need to figure out our a. So remember with hyperbolas, a is always first, so a is 4, which makes a 2. B squared is also 4, which makes b also 2. Then we can find c, so b squared equals c squared minus a squared, which gives us c squared is 8, so c is 2 root 2. So because this time x is first, that means we're going to be moving out 2 in the x direction, right? Our hyperbola is going to be opening up left and right instead of up or down. So I'm going to go out 2 and 2. Those are my vertices, so that brings us to 0, negative 5, and 4, negative 5. The foci are going to be made from the C, so we're moving out left and right from the center to root 2. So the center here is at 2, so it's going to be 2 plus 2 root 2, negative 5, and then 2 minus 2 root 2, negative 5. Now, asymptote. Now remember, it's always y. So it'll be y plus 5 equals plus or minus, and then x minus 2. And then I need to find the slope here. So to find the slope, we always do y over x. So in this case, with the y would be 2. With the x would be 2, right? We're always doing the square root of those numbers, not actually 4, but the square root of 4 would be 2. So 2 over 2 simplifies to 1. So there is our asymptotes. So now from the center, we're going to move 1, 1, 1, 1 in each direction. There's our first guy, and then the other way, negative slope. There's the other one. Now we can finish drawing our hyperbola. The last thing that we need is the transverse axis. So because this is along, it's going to be parallel to the x-axis. And if we were specific, that's at the line y equals negative 5.